Okay, so here we are, Module 2, Lesson 2. This is called Interpreting Expressions. There's no PowerPoint for this one because there's not really much to put in a PowerPoint. The best way to learn these or to teach these is just to get into them and do them. All right, so what you'll need now is you'll need to get out your worksheet. Algebra 1, Module 2, Interpreting Expressions, Worksheet 2.2. Okay, so first off, if you pay attention up here at the top, you've got a word wall. All right, these are some words that help identify key mathematical operations, like addition. Words like more, sum, increase, plus, total, added to, combined, include. Those are words that typically mean addition. Subtraction, less, difference, decrease, minus, diminish, exclude, remove, take away, and reduce. Those words typically mean subtraction. Multiplication, times, product, twice, doubled, triple, the word of, multiple. Those mean multiplication. Division, divided by, quotient, separated, split, and cut. Ones that can be tricky are words like than, from, and to. And we'll see some kind of examples of those as we move through the worksheet. Okay, so we're going to scroll down and we'll take a look at a couple of these. We're going to be focused here on the left side, the odd number problems. All right, so let's start with this first one. The sum. The sum of 3 and an unknown number. Well, what does sum mean? Sum means addition, so we're going to add. All right, sum of 3 and an unknown number. Okay, well, how do we typically write an unknown number, or how do we represent an unknown number in math, especially in algebra? We use a variable, so I'm going to say x. All right, so there's my expression, 3 plus x. 3 plus x. All right, so let's move on to the next one. A number doubled. A number doubled. Well, when you double something, you multiply it. So it's going to be 2x. All right, the next part we need to look at, reduced. Reduced. All right, whenever we reduce something, we subtract. It's going to be reduced by 5. All right, so there's my expression, 2x minus 5. All right, now the next one's going to be a little bit tricky. Let's start with the first part. The product of 3 and an unknown number. The product of 3 and an unknown number. Well, what does product mean? Product means multiplication. So the product of 3 and an unknown number. Well, the way we would do that was we'd say 3 times x, or 3x. Next part, diminished. Diminished. What does diminished mean? It means subtraction. All right, and what is it subtracted, or what's being subtracted from it? What's it being diminished by? Well, in that case, it's going to be 8. And so 3x minus 8. And there's my solution. All right, so number 7. The quotient of a number tripled and 6. The quotient of a number tripled and 6. All right, so I'm going to pause the video here and give you an opportunity to try it, and then you can come back and see how you did. Okay, so here we are. The quotient means division. So there's a couple different ways we can write this. I'm going to put an or here. Let's talk about the first way. We can use the division sign. The quotient of a number tripled and 6. So typically, whenever you're going to find the quotient of something, whatever is listed first comes first or goes on top of the fraction. Whatever comes second is your denominator. So in this case, a number tripled, that's going to be 3x, and then of course it's going to be divided by 6, or you could say 3x divided by 6 here. Okay, let's look at number 9. 10 subtracted from twice a number. So I'm going to pause the video here and give you an opportunity to try it on your own. Okay, got to be careful here. 10 subtracted from twice a number. All right, so a lot of people, what they do is they see this 10 subtracted, they put the 10 first, but 10 is being taken away from twice a number. So this twice a number needs to come first. So 2x, and then we're taking 10 away from it. So 2x minus 10. 2x minus 10. Okay. Let's scroll down. Let's try these next two. 4 of a number increased by 7. 4 of a number increased by 7. All right, I'm going to pause the video here and let you try this one. Okay, so let's start with this part. 4 of a number. So that's going to be 4x, and it's increased by 7. Well, if it's increased, we're adding. All right, so there's my expression, 4x plus 7. All right, let's try this one. 5 added to a number squared. Ooh, that one's tricky. All right, so I'm going to give you just a moment. Pause the video and think about what you need to do here and see what you can come up with. All right, so welcome back. So we have 5 added to a number squared. Let's talk about this one real quick. A number squared. That's a number times itself. And the way we typically write that is x squared. Now for this next part, 5 added to a number squared. So plus 5. You could also have it written as 5 plus x squared. 5 added to a number squared. That one's fine too. All right, so let's talk about this one. Number 15, Laurie is 4 years younger than Sean. Write an expression that represents Laurie's age in relation to Sean. So what we're really focusing on here is Sean. So we'd say Sean. All right, and we don't know what Sean's age is. So we're just going to say X. Okay, so Laurie, to find her age, would be Sean minus 4. All right, so there is my answer. Laurie's age in relation to Sean, so X minus 4. All right, number 17, Jerry worked 2 hours less than 4 times as many hours as Katrina worked. Write an expression that represents the number of hours Jerry worked in relation to Katrina. All right, so let's talk about this one. We have Katrina. We don't know how many hours she worked, so we'll just put X hours. All right, then we have Jerry. Now, Jerry's formula or algorithm here is going to be in relation to Katrina. So that's where this comes in up here. Jerry worked 2 hours less than, so we're going to be subtracting 2. 4 times as many hours as Katrina. Well, Katrina's hours are X, so 4 times that would be 4X. All right, and then there's my expression for Jerry. To To find Jerry's hours, we would do 4x minus 2. All right. Number 19. In an isosceles triangle, a triangle where two of the three sides called legs are equal, the legs are 1 unit less than twice the length of the base. If the length of the base of the triangle is represented by x, create an expression that represents the perimeter of the triangle. All right, so a couple things real quick. Let's just draw a picture. Sometimes a picture helps. Obviously, this isn't to scale. But we know that this side and this side are equal. All right, it says the length of the base of the triangle is represented by x. So here's x. All right, here, the length of the base of the triangle is represented by x. It also tells us the legs are 1 unit less than twice the length of the base. So that's going to be 2x minus 1 on both of these because they're equal. It's an isosceles triangle. All right, and then they want us to write an expression that represents the perimeter of the triangle. Well, if you remember, the perimeter is just where we add up all the sides. So what that means is we're going to do 2x minus 1 plus 2x minus 1 plus x. So at this point, we're just going to combine like terms. So we can combine the 2x, and the x. That's going to give me 5x. And then, of course, we can combine the negative 1 and the negative 1, which will give me a negative 2. So the perimeter is equal to 5x minus 2. Okay, guys, for your homework, you need to do the even number problems. Take a picture, turn it into a PDF, and submit it through Google Classroom. All right, thanks.